Hi everyone, welcome back. In this video we are going to explore the mind map of a basic chemistry course. This mind map serves as a visual guide to the essential concepts and skills students will encounter throughout the course. Our goal is to make learning more accessible by using simple analogies and clear explanations. Let's dive in. Atoms are like building blocks of matter. Think of them as Lego pieces, each with its unique shape and color based on the number of protons in its nucleus. Elements are like pure breeds of these Lego pieces. All the pieces of a single color represent one element. When these Lego pieces snap together, they form structures known as compounds. If only two or more atoms join together, it's called a molecule. For example, water, H2O, is a molecule made of two hydrogen atoms and one oxygen atom bonded together, much like snapping two smaller Lego pieces onto a larger one. Calculating the number of electrons is simple if we remember that atoms are neutral by nature, like a balanced seesaw. The number of protons, positive charges, is always balanced by an equal number of electrons, negative charges, in a neutral atom. Isotopes are like siblings in the same family. They belong to the same element but have different weights due to varying numbers of neutrons. Isobars are like neighbors who live in different houses but have the same weight. Isotones are like pen pals from different parts of the world who have the same number of neutrons but belong to different elements. Mass and weight are often confused, but a simple analogy is comparing them to the size of a watermelon. Mass versus how heavy it feels when you lift it, weight. Mass is constant, but weight depends on gravity. You'd feel lighter on the moon than on Earth, but your mass stays the same. Acids and bases are like opposites in a taste test. Acids taste sour, like lemons, while bases feel slippery, like soap. If you've ever mixed lemon juice with baking soda, you've seen their opposite nature in action. They fizz and neutralize each other. Acids release hydrogen ions, H, in water, while bases release hydroxide ions, OH. Electrolytes and non-electrolytes are like conductors and insulators for electricity in water. Salt water conducts electricity because the salt breaks into charged particles, ions, in water. Sugar water, on the other hand, doesn't conduct electricity because sugar doesn't form ions. This explains why sports drinks contain electrolytes. They help transmit electrical signals in the body. The periodic table is like a library catalog where elements, books, are arranged into specific categories. Each row, period, is like a row of books, while each column, group, is like a shelf of books with similar content. Elements in the same group have similar personalities or chemical properties. For example, elements in group 1, alkali metals, are like explosive personalities because they react violently with water. Periodic properties like atomic size, ionization energy, and electronegativity change predictably as you move across the table. Atomic size decreases from left to right, like squeezing people closer together on a crowded bus. Ionization energy, the energy needed to remove an electron, increases as you move to the right, like tightening security to protect a valuable item. Electronegativity, the ability to attract electrons, also increases as you move to the right, like a magnet's pull getting stronger. Chemical reactions are like kitchen recipes where ingredients, reactants, transform into new dishes, products. Combination reactions are like assembling furniture from individual parts to create a single item. Combustion reactions are like campfires where wood fuel burns in oxygen to release heat and light. Decomposition reactions are like breaking apart a piñata into smaller pieces when it's hit. Balancing chemical equations is like balancing a budget. What you spend, reactants, must equal what you earn, products. Each type of atom must be accounted for on both sides. If one side has more of an element than the other, you must adjust the numbers to keep everything balanced. Bonds are like glue that holds atoms together in molecules. Ionic bonds are like magnetic attractions between positive and negative charges, like Na and Cl in salt. Covalent bonds are like sharing toys where two atoms share electrons equally. Polar covalent bonds are like unequal sharing of a blanket, where one side pulls it more, like in H2O where oxygen pulls the electrons closer. Non-polar covalent bonds are like fair sharing of a blanket, where both sides pull it equally. Percentage composition is like ingredients in a recipe where you calculate the proportion of each ingredient, element, in the final dish, compound. Empirical formulas are like simplified recipes where you write down the simplest ratio of ingredients. Molecular formulas are like the full recipe where you list exactly how many of each ingredient. Unique gas laws describe how gases behave under different conditions. Imagine a balloon to understand Boyle's law, Charles's law, Henry's law, and Avogadro's law. Boyle's law says that if you squeeze a balloon, reduce its volume, the pressure inside increases. This is like squeezing an air-filled water bottle. Charles's law says that when you heat a balloon, it expands because gas particles move faster and need more space. Think of a balloon left in the sun versus one left in a freezer. Gas laws describe how gases behave under different conditions. Imagine a balloon to understand Boyle's law, Charles's law, Henry's law, and Avogadro's law. Boyle's law says that if you squeeze a balloon, reduce its volume, the pressure inside increases. This is like squeezing an air-filled water bottle. Charles's law says that when you heat a balloon, it expands because gas particles move faster and need more space. Think of a balloon left in the sun versus one left in a freezer. Henry's law explains why soda goes flat when opened. More gas, carbon dioxide, stays dissolved in a cold, pressurized soda can, but it escapes when the pressure is released. Avogadro's law states that if you blow up a balloon with more gas molecules, it gets bigger. The volume of the gas increases as the number of particles increases, just like inflating a balloon. By the end of this course, students will have a toolkit of skills that include identifying atoms, elements, compounds, and molecules. They will be able to calculate the number of protons, neutrons, and electrons in atoms and isotopes. Students will classify substances as acids, bases, electrolytes, and non-electrolytes. They will use the periodic table to predict element properties and trends. They will learn to write and balance chemical equations. Students will differentiate between types of chemical bonds, ionic, covalent, polar, and non-polar. They will calculate percentage composition and use empirical and molecular formulas. They will also apply gas laws to real-world situations like weather balloons, soda cans, and air pressure changes. This mind map serves as a roadmap to guide students through the course, emphasizing conceptual clarity and relatable analogies. By the end of the course, students will be equipped with a deeper understanding of chemistry's role in everyday life and the skills to think critically about scientific phenomena. The course provides interdisciplinary knowledge, fosters environmental awareness, and improves communication skills, benefiting students across various majors in both academic and professional settings. Thank you for watching.